So in this video, I just want to go over some examples of how to find the number of protons, neutrons, and electrons in different atoms. So we're going to start by reviewing really quick ways to write atomic information. So you can find atomic information just by using your periodic table in an element that looks like this, for example. But sometimes we use nuclear notation, so you need to know how to find atomic information based on that too. So this right here is one way that we can show atomic information, all right? In this type of setup, we have our element symbol right here. Our atomic number, which is the amount of protons, is going to be right here in the lower bottom corner. This is not always included though, just sometimes. But notice that here our atomic number or our number of protons is in the bottom left corner, while in the periodic table it's in the top left corner. So just be careful with that. You can always compare it back to your periodic table if you're unsure. And then our mass number is right here. That is the number of protons plus the number of neutrons. And the mass number in nuclear notation is not always going to be the same as the mass number from your periodic table, because the one from your periodic table is just the average atomic mass. In the nuclear notation, it's giving us the specific mass number for that atom. We might also see it like this in dash 15. The only information that we can get from this is our mass number, which again is our protons plus our neutrons. One more thing I left out, I forgot to mention, is that sometimes in nuclear notation we're given a charge. Not always though, but if we are given a charge, it's designated by a negative number or a positive number, but we aren't always given that. Okay, and then let's just compare the periodic table to nuclear notation one more time. For our periodic table, we have the atomic number, which is the proton number right up here. And then in nuclear notation, it's down here. Our average atomic mass can be found at the bottom of that box, while our mass number for our nuclear notation is found here, and it does not always equal the one from the periodic table. These charges right here are your oxidation states, but don't worry about that. We won't use those too much. But this +1 on nuclear notation is designating the charge. So for this atom, we have a +1 charge. Okay, finally, let's try some examples. Let's say you are given this nuclear notation of manganese-55, and it wants to know how many protons, neutrons, and electrons you have given Mn-55. So what I did to start was I just gave you the little element symbol from the periodic table down here just to make it easier for you to see what I'm looking at too. So to start, I would start by finding the protons, because it's really easy to find if we have a periodic table in front of us. So the number of protons we have is going to be equal to our atomic number, which is this 25 right here. We aren't given any atomic number in this nuclear notation, so we do need to use our periodic table to find how many protons we have. So that 25, that atomic number, is equal to our number of protons, so we can say for protons, we have 25. Next, let's look at neutrons. Neutrons. Okay, so for neutrons, the number of neutrons is equal to the mass number minus the number of protons. Let me just write that out for you. So neutrons equals mass number minus protons. Okay, in this case, we actually are given a mass number in our nuclear notation of 55. So we're going to use that for our mass number. So for our neutrons, that's equal to our mass number, which is 55, minus our protons, which we found was 25. If we do that math, we see that we have 30 neutrons. Notice that I did not use the average atomic mass from the periodic table. I used the mass number from the nuclear notation we were given. And then finally, we need to find how many electrons we have. In this case, we aren't given a charge on this nuclear notation. So what we can do is we can assume that the number of electrons is equal to the number of protons, which is 25. So for this question, we had 25 protons, 30 neutrons, and 25 electrons. Let's try another one. Let's say we were given manganese 54 this time. A little bit different than the last one, but we can start it the same. First, we want to know how many protons we have. Again, I'm going to look to my periodic table and find my atomic number, and I see that it's 25, and I know that my atomic number is equal to my proton number. So for protons, I know that I have 25 of those. For neutrons, remember that that is my mass number. Let me just write it down again. Neutrons equals mass number minus protons. So for this one, our mass number is 54. So we're taking the mass number minus the protons. And for this one, when we do the math, we get 29. So that was the neutrons. Finally, for electrons, we are not given a charge for this nuclear notation, so we can assume that our electrons are equal to our protons, 25. So for this Mn-54, we have 25 protons, 29 neutrons, and 25 electrons. Okay, this one's a little bit different nuclear notation. So let's see how we find protons, neutrons, and electrons for this. So for this type of nuclear notation, we are actually given our atomic number. It's at 30 right there. So we can also check this by looking at our periodic table, and we can see that the atomic number is indeed 30 on our periodic table. So remember that the number of protons is equal to the atomic number. So since our atomic number is 30, we know we have 30 protons. Okay, next, to find neutrons, let's just write our equation again so we get used to it. Neutrons equals mass number minus protons. In this nuclear notation, we're given our mass number right here. It's 65. So for neutrons, we're starting with that mass number. We take 65. We subtract the protons, which are 30. If we do that math, we get 35 neutrons. Finally, for electrons, we don't have a charge. If we did, it'd be right here, but we don't have one. So we can assume that our electrons are equal to our protons. So that means we have 30 electrons. So for this zinc atom, we have 30 protons, 35 neutrons, and 30 electrons. Okay, let's look at this tin example. So that's what Sn is. It's the element tin. So it wants to know how many protons, neutrons, and electrons we have. Similar to the last one, to find our protons, we look at the atomic number. In nuclear notation, it is in the bottom left corner. It's at 50. Or on our periodic table, we can see it's at 50 right there. So our protons, our protons are just equal to that. So we can say for protons, we have 50 of those. Okay, now let's move on to neutrons. Remember that neutrons equals mass number minus protons. Our mass number was given to us right there. It's 119. So we do 119 minus the protons, which is 50. And if we do that math, we get 69 neutrons for this atom. And then finally, electrons. We aren't given a charge for this, so no charge. So that means that our electrons are equal to our protons. So we have 50 electrons. So for this example, we have 50 protons, 69 neutrons, 50 electrons. Okay. I have a few more examples here. I want you to try to do these on your own, but I'm going to work through them too. But I want you to try them first. Okay, or if you're good with these examples, you can skip forward to the end where I do a different type of example. So let's start with this one up here. So we're given an iodine atom in nuclear notation, and we want to find protons, neutrons, and electrons. So let's start with protons. I'll just write P for that. We can find our protons by looking at our atomic number, which is 53. So we have 53 protons. Neutrons is equal to the mass number minus the protons. In this case, our mass number is 127. So for neutrons, I'm going to do 127 minus 53. Let me do that math really quick. 127 is 74. So we have 74 neutrons. We are not given a charge, so our electrons is just equal to our protons. Okay, next, zirconium. We're given zirconium-91. Okay, I put your periodic table symbol up here to make it easier to find your protons. Remember, our protons are equal to our atomic number, which is 40. So we have 40 protons. Our neutrons are equal to our mass number, which is 91, minus our protons, which is 40. So if we do that math, we get 51 neutrons. And our electrons are going to be equal to our protons since we have no charge. Okay, moving on. Now we have xenon-132. Okay, again, I'm going to use my periodic table for this one to find my atomic number, which is 54. And my atomic number is equal to my number of protons, so I have 54 protons. For neutrons, I'm going to take the mass number, 132, minus my protons. If I do that math, 132 minus 54, I get 78 neutrons. And then my electrons are just equal to my protons since I have no charge. Last one. Tungsten has a symbol of W. We are given the atomic number for this one, 74, matches up with our periodic table. So our protons are equal to our atomic number of 74. Our neutrons equals our mass number, 184, minus 74. And that is equal to 110. I cannot do math in my head. And then finally, we are not given a charge, so electron is equal to our protons, which is 74. Okay, 3 more examples for you real quick. Sometimes you're going to have to find protons, neutrons, and electrons based on the periodic table instead of a nuclear notation like that. So I wanted to show you how you can do that really quick. It's pretty simple. To find protons, again, it's what we've been doing. For protons, we look at our atomic number right there. We have 29 for this one. For neutrons, we're going to take our mass number minus protons. When we're just using the periodic table, we have to use our average atomic mass though. But instead of using 63.546, we're going to just round that to the nearest whole number. 63 is going to round up to 64. So for our neutrons, we're going to take that average atomic mass, 64, subtract our protons, and we get 35 neutrons. And then we are not given a charge, so we have 29 electrons to match with our protons. Let's try another one. Let's look at potassium. So again, to find protons, we look at our atomic number. It's 19, so we have 19 protons. Neutrons is the mass number, which rounds to 39, minus the protons, which is 19. If we do that math, we see we have 20 neutrons. And then for our electrons, we are now given a charge, so our electrons are going to match our protons. We have 19 electrons. Last one, for beryllium, has an atomic number of 4, so that's equal to our number of protons, which is 4. For neutrons, we're going to take our mass number, which rounds to 9. We're going to subtract our protons, and we're going to get 5 neutrons. And then our electrons is going to be equal to the number of protons we have, which is 4. Hopefully that helps.